Hey kids, it's your 7.4a problem set key. Woo! Let's do this. All right, we got some 45, 45, 90 triangles. So that's talking about the angle measures. So it says use the triangle below to answer the following questions. So we're looking over here. We're going to classify this triangle by its angles and sides. It's a right triangle, which is, so by its angles means right, obtuse, or acute. And then by its sides, two sides are congruent, so it's a right isosceles triangle. Right isosceles. It could be a equilateral triangle or a scalene triangle, or the other options there, don't forget. How big is each acute angle, and how do you know? Well, since these angles are congruent, and one angle is 90, we know that they're both going to be 45 degrees. How long is the other leg? The other leg is 5 because it's an isosceles triangle. It's an isosceles triangle. All right. Find the length of the hypotenuse. Okay, so we know this is 5. Remember, this is called the hypotenuse. So we're going to use Pythagorean theorem. A squared plus b squared equals c squared. So let's do this. A squared is, well, A is 5, so 5 squared. B is also 5. Remember, it doesn't matter which one you call A or B, but that hypotenuse always has to be called C, or it has to be the biggest one. So we get 25 plus 25 is 50 equals C squared. Square root both sides. And you get C is equal to the square root of 50, which we're going to simplify. Square root of 25 times 2. Square root of 25 is 5, so you get 5 radical 2. And there you go. All right. So this is called a special right triangle because we'll talk about it a lot with 45, 45, 90 degree angles. We're going to find the hypotenuse of each of these. So similar to the last problem, this is going to be 3. And we get 3 squared plus 3 squared equals c squared. Here's my c. So you get 9 plus 9, which is 18, equals c squared. So c equals the square root of 18, which is 9 times 2, and the square root of 9 is 3. So you get 3 radical 2. Okay, jumping down here. We know that this is 9. We'll call this c. We get 9 squared plus 9 squared equals c squared. That's 162 equals c squared. So you get c equals the square root of 162, which is the same as 81 times 2, and the square root of 81 is 9, so you get 9 radical 2. Jumping over to this guy, this is going to be a 4. This is c. So we get 4 squared plus 4 squared equals c squared. That's 16 plus 16. So you get c equals the square root of 32. But the square root of 32 is 16 times 2. And so you get c equals 4 radical 2, because we can do the square root of the 16 and keep the 2 underneath. Okay, this one's a little weirder because of the number square root of 3. But that's okay. This is still square root of 3. This is still c. Whoops. And we can do square root of 3 squared plus the other square root of 3 squared, so a squared plus b squared equals c squared. You square a square root, they just go away. You get 3 plus 3 equals c squared. So c squared equals 6. So c equals the square root of 6. Now, for something later on, actually, let's go later on first. So it says, looking at the side lengths of all the 45, 45, 90 triangles on this page, can you recognize a pattern? Well, what we know, I guess we know two things here. The legs are congruent because it's a 45, 45 triangle. The legs are congruent. Remember that symbol there. And the hypotenuse, the side across from the 90 degree angle, The hypotenuse is always radical 2 times the leg. Look at this. We were given a leg of 3. The hypotenuse is 3 radical 2. We were given a leg of 9. 9 radical 2. 4. 4 radical 2. Now this one's weird. Radical 3 and then radical 6. But if we do radical 3 times radical 2, which is the pattern we've discovered, you can just multiply the numbers that are underneath the radical, and you get radical 6. So it does, in fact, work there. I'm going to erase that so people who are just looking at the key don't get confused, but that one does work with our pattern. All right, number 7, can you find expressions for the other leg and the hypotenuse in this triangle? So now we have this written in a more abstract way, no numbers, that's all that means. So if this were an x, remember the hypotenuse is always radical 2 times whatever the leg is. So you just say it's x times radical 2. That's all you got to do. Ooh, jumping on down here though, what if we know the hypotenuse first in a 45, 45, 90 triangle? Remember, it's got to be a 45, 45, 90 for this to work. So if we know that the hypotenuse is radical 2 times the leg, then we can take this and divide by radical 2 to go backwards. So we can say, hey, a leg is equal to 4 radical 2 divided by radical 2. And then those cancel out and you just get 4. So each leg has a value of 4. What about on this one? Same thing. One of the legs, or each leg really, is equal to 8 divided by radical 2. Because remember, to get this, we multiplied a leg by radical 2. So now we're going to divide to go backwards. So when you know the hypotenuse, you just divide by radical 2. Now this is where we had to multiply top and bottom by radical 2, called rationalizing the denominator, getting the square roots out of the bottom. And that gives us 8 radical 2 over 2, which is equal to 4 radical 2. So now our legs have a length of 4 radical 2. And if you want to, real quick, I'll show you. Take the leg, 4 radical 2, multiply by radical 2, and that should give us the hypotenuse. That's what we set up here, right? Here, and then here we showed it in a picture. So if we do 4 radical 2 times radical 2 times radical 2 is just 2. And 4 times 2 is 8. So we took a leg, multiplied it by radical 2, and got the hypotenuse. Okay? Again, I'm going to erase that for people who are just looking at the key. That would be confusing. And so number 9 says, is there a pattern here too? So yes, I already said it. We just divide the hypotenuse. So if you know the hypotenuse, divide it. Divide the hypotenuse by radical 2. All right, just a couple practice problems here. Let's find the missing lengths. So here we are given a leg. We automatically know the other leg is 7. And the hypotenuse is radical 2 times that. There you go. Now we know how the hypotenuse is 20. So we're going to take 20 and divide it by radical 2 to get the legs. Okay? So then you got to multiply top and bottom by radical 2 over radical 2 to rationalize the denominator, giving us 20 radical 2 over 2. And remember, if both of these numbers can be simplified just like a normal fraction, ignore the radical part when you do this, then we can simplify. And when we do that, we're going to get 10 radical 2. So both of our legs have a value of 10 radical 2. And that is it. Congratulations.